All right, so everybody has a workbook. It's only like 4 pages, I think 8 problems or so. If you're doing this online, I'll be posting a PDF format or even a PDF format of this exercise. You want to try to print it out before you watch the video. Even if you guys are going to rewatch this video later, have an extra copy. Go through these over and over. The only way you get better at subnetting is by doing them. Okay, folks? So I'll be posting this all in week, whatever we're on now, 7 or 8. And the video, if it does record, I'm really hoping it is going to record, will also be uploaded onto YouTube if that don't give me any trouble. And we'll just go at it. Okay, guys? So no questions? We're just going to get ready to begin? All right. In order for me to do this, I'm going to step back a few. And so in this particular example, problem number 8, I'm given a network address of 200.175.14.0. And let me open up a packet tracer file and show you that class example we've been working with all week long. And it shouldn't come as a shock. Over on the other whiteboard, I basically had this logical topology written out, correct? You guys remember seeing that on Monday, and then last week I drew it out saying to you, this is it. Naturally, we said we had 4 networks, correct? And for what you know right now, you know that each of these networks, this LAN, this WAN, and these 2 LANs, must have their own unique network address. We good about that? If I'm given a network address of 200.175.14.0, it wasn't given to me by free. I had to go out and buy it. Now, typically, we arrange network addresses by class, A, B, and C. And the class with the most hosts would cost the most. It's that simple. I always like to use the analogy of a trailer, a home, and a mansion. Which one's going to cost more? Which one gives you more space? More room, ironically, more room for rooms, for partitions, right? And a classful environment. By the way, which class would this represent? Class C. How did you determine that? Oh, okay. So you followed the human way of looking at it, and you have your tables memorized, your classes memorized. A goes from 0 to 127, B goes from 128 to 191, and C goes from 192 to 223. That works out well. On the exam question, it's going to be maybe 8 points, and I will ask you guys to explain classful addresses using binary. Correct? Clear about that? Now, how do you know this was a class C using binary? Brian? Because the first octet looks like this in binary. So let's just take this and convert it into binary. I have a 1 in the 128, correct? I'm also going to get a 1 in the 64. It gives me 192. I'm going to get a 0 here. And then I'm going to get a 0 for, so this was what, 32, 16. 8, I get a 1 in, 4, 2, and 1. So I have 1, 2, 3, 4, 5, 6, 7, 8. I'll bring up my spreadsheet later. But for now, this is just rough math. I look at the very first bit of my very first octet, and it's a 1. If it's a 1, what does that tell me to do next? Just leave it there. OK, then wait a second. If it is a 1 here, what do I do next? Go to the next bit, right? Because if it was a 0, it would be a class A. If it was a 1, it could be a class B or a class C, correct? So you go to the next bit. If there was a 0 in this place, it would be what class? B. But it's a 1. What do you do next? Because now it could be a D, correct? You go to the next bit, and it's a what? 0. So therefore, this is telling you that those 3 bits represent a Class C license. Okay? Let's see. Marcus, could you do other problems before I can get back to you? What's that? It should be. It's exam 1 makeup.
No, it was the, I wanted to get that chapter 5.
Oh!
Yeah. I mean, I didn't care if I got points.
I thought it was exam 1. Never mind. Then I'll just set that up later for you.
Okay.
Yeah, I'll send you an email tonight.
All right.
You're talking about the Cisco assessment.
Yeah.
Okay, leave that there. I'll just grab it later.
All right.
Sorry about that.
I wanted to at least be able to take it so I can add the
Yeah.
information.
Yep. Sorry about that. All right. So, folks, we see that this is Class C. And if I have a classful addressing scheme, I can only use this address block one time, correct? So I can only use it on one of these networks. I can't use it on the other ones. Why not? What's the big issue if I try to use that address block over again?
Error when you try to send it.
When I try to send a packet out, imagine this. This network is represented by this network address, and these two networks are also represented by the same network address. Well, my computer, when it goes to send it, will say, hey, the destination packet belongs to the same network that I'm in. Don't bother the router. Right? We'll see that later. But since it's not going to bother the router, the packet will never get to PC5 if that's where it was intended to go. So what must I do if I was doing classful addressing? This must have another network address, and that might be 200.175.15. Because when we determine class, what can we deduce from our IP address? Now that you know this is a Class C, what can you guys tell me about this address? First 3 octets of the network. Very good. So if you need to get another classful address, you're going to have to call up the company up and be like, look, can I also buy 200.175.15? Can I also buy .16? And can I also buy .17? Now, that would be pretty wasteful for this network right here. Because the third thing you guys can deduce, sorry, we're at the second thing right now, right? The second thing you can deduce after determining class is not only what part represents the network, right? But also what else? Which part is the host, and therefore how many hosts a network can handle. We clear about that? So, if I have a Class C address, you guys told me at the very first 3 octets, 1, 2, and 3. So let me just specify here. First octet, second octet, third octet. So, first, second, and third. Is it okay if I just draw a line right here to divide the third from the fourth? Why do I want to separate the fourth octet from all the others? Because anything left of the line represents the network, and anything to the right of it represents the host. So not only can you tell by looking at an address using classful techniques what the network portions of an address are, but you can also tell me the size of that network. How many bits in this particular example are used to represent the host? How many bits total are used in an IPv4 address? 32. If 24 of those bits are used for the network, then 8 bits are going to be used for the host. Now I'm going to teach you guys a formula that's been used quite a bit in computer science. It basically shows you the number of possibilities you can arrange those 8 bits to make unique results. You take 2, because we're dealing with binary, and you raise it to the number of bits. In this case, I'm going to raise it to the number of host bits. If I take 2 raised to 8 host bits, what am I going to get as an answer? What's 2 raised to 8? You need to get these places memorized. 256. And that tells me how many total hosts this network can handle. Okay? So if I have 2 raised to 8, a Class C address can represent 256 total hosts. What does that mean about usable? What we call the signable address? 254. So going back to my example, with that wide area network, how many hosts did I have in there? Only 2. And if I were to use a Classful address and I spent, let's say, $1,000 a month for this address, and all I need is 2 addresses, I'm wasting a whole lot of addresses, 252 to be exact, plus I'm wasting a lot of money. So the idea today is to break that traditional Classful boundary and decide to draw this line anywhere to accommodate our exact needs. We clear about that? Before I do that, I want to finish up Classful. You said 2 things we can determine by looking at an IP address. It's the host portion and the network portion, and the number of hosts the network can handle, correct? What's the third thing you can tell me about this? What's the default subnet mask? I'm just going to call it default mask for this address if we're a Class C. Well, folks, what is the purpose of a subnet mask? I said this yesterday at the end of class. To hide the network, sorry, the host proportion, the host portion from the IP address to reveal the network. Clear about that? Let's make this top row the IP address. What is our IP address that we're given? Right? Look at your problem. What is 200 in binary? We got a 1 in the 128. I don't know why we keep these around. Close. We'll use green. There we go. A 1 in the 64, 0 in the 32, 0 in the 16, a 1 in the 8, and then all zeros. Now, I feel comfortable with this because I've been doing it for a lot of years now. I don't expect you guys to feel comfortable with it. But in order to get comfortable with it, guess what you have to do? And the same thing I had to do when I was first taught this technique. Practice, practice, practice. Right? So I can say that 128 plus 64 is 192. 192 plus 8 gives me 200. And that was the number I was looking to convert. Correct? What are we going to do for the next one? Ryan, how are you going to convert the next number? 175. What is it going to look like in binary? A 1 in the 128. So you need to tell me that. Because you guys could put a 1 here in the 1. I have no idea, so you need to tell me place. So 1 in the 128. What are you going to do next? A 0 in the 64, because we know that 128 plus 64 would give me 192, and that would go way over the 175, correct? So now we have 128. What's the next one? So if I take 128 and 175 and remove 128 from it, what am I going to get? It's going to be a 7. It's going to be what? 37? 47? 47 seems to be about right. So 47. It looks like I got to put a 1 in the 32, right? Check my math, folks. I do make mistakes. So 175 minus, what did we say? 128. Let me do that so I actually do some quick math here. I'm going to get a 7 here. And yes, so it is going to be 47. So 47 minus 32 is 15. What's the number right before 16? 15. The number right before 16 is 15, right? Look at what I did here. If I know I'm looking for a 15, I know that a 16 would be a 1 followed by all zeros, correct? What would the number be before a 1 followed by all zeros? All 1s, then a 0. Does that make sense, guys? All right, let's look at the next one. Michael, what do you think? How are we going to do 14? I gave you the hard one.
0, 1, 0, 0, 0, 1, 0.
Not bad. All right. Which one of these numbers comes close to 14 without going over? Put a 1 in there. Subtract that number from your number you're trying to convert. Restart. Which one of these numbers comes up to that new number? Put a 1 in it and proceed. Correct? Another way of doing this is quick addition. What am I going to put in here for the host? Ian.
All zeros.
You had the hardest one out of the bunch. You should get extra credit for doing this one. My last class said they're going to beat up the extra credit kid, so you better be careful. These other students might beat you up. All right, so we have all zeros here because we just converted this 0 up here into binary. The question was, what is the subnet mask? What is the default subnet mask? Let's make that in red. Remind me, what octets represent the network part?
There's 3.
Subnet mask can only contain either zeros or ones in it. Subnet mask is designed to hide the host part from the IP to reveal the network part, correct? Since an IP address can only consist of 2 parts, a network part and a host part, what are we going to use in binary to represent the network part? A 1. What are we going to use in binary to represent the host part? A 0. If the first 3 octets represent the network part, then I'm going to fill in those 3 octets with all 1s. How many 1s am I going to put in here? 24. And that's what we call the network prefix. I told you the network prefix and the subnet mask are one and the same. And what I mean by that is they both have the same task of telling a device how to calculate the network address. The network prefix is telling me the first 24 bits represent the network. Hence, the last 8 bits would represent the, and what would I put in there for those bits? So the default subnet mask is me simply taking these 1s and converting them back into decimal, which would be what? Memorize that. Just like you guys have 0 memorized in binary, memorize all 1s. All 8 1s are going to be 255. Now I know what you're thinking. 2 raised to 8 gives you 256. We just did the math over there, right? How many fingers do I have, guys? Include the thumbs if you want to be smart. 10 fingers. But they go from 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. We always count 0 as a number. So I have from 0 to 255, which gives me all 1s, correct? So what's this going to be? Evan, give you another hard one. And this one's going to be? Bob, I'll give you that one. And what's the last one going to be? So my subnet mask, my default subnet mask for class C would be 255.255.255.0. Folks, the reason why we have to learn this is because we typically assign addresses from a classful block and then we subnet them. Second, routing protocols like RIP version 1 is a classful addressing protocol. Third, you notice when we were in Packet Tracer or when you guys are configuring IP addresses on your end devices that when you type in a number like 200.175.14.27, and when you go to click on the subnet mask, the operating system does what? automatically fills it out for you as 255.255.255.0. What would the default subnet mask be for a Class B address? 255.255.0.0. What would the default network prefix be for a Class B?
16.
/16. What about a Class A? 8. Or 255.0.0.0. Good about Classful, because we're going to turn it upside down, and now we're going to do something really different. And we're going to look at the problem, and the problem is going to give us two pieces of conditions. And we have to make sure that we meet these conditions. The first condition, they're telling us we need how many subnets? Now, in our example that we've been using, how many subnets would I need? And where are subnets coming from? Well, folks, I'm being cheap. I'm buying a Classful C address. I'm buying a trailer. And now I'm having my family move in. And I don't want to be sleeping in the same bedroom with them. So I have four, let's just say four, there's 4 of us living in this trailer. We good about that? And so I need 4 bedrooms. So what could I do? I could take the trailer and divide it up into 4 equal spaces. Does that make sense? And how would I do that? Look behind you. Do you guys see that foldable wall there? Originally, this classroom would be able to handle about 40 to 50 students. Originally. School's having a problem with scheduling. We had more instructors than we did classrooms. So what did we do? Took a large classroom like this one and cut it in half. What did I gain by taking this classroom and cutting it in half? And putting a door in each of these classrooms. I could be teaching in this classroom while somebody else is teaching in the... This is those people that are playing the damn lights with us. Right? Same time that I'm teaching. I'm taking this address block and I want to divide it up into 4 equal places so I can accommodate all my other local area networks, correct? Using my topology that I showed you guys with Packet Tracer. And this particular example, they're telling me all you need is 3 rooms. Now, I'm thinking this conceptually, and I'm thinking they probably have 2 local area networks and 1 WAN to connect those 2 local networks. You guys getting the same picture? To me, what I did is took 1 router and had 2 networks going off of that, plus a WAN. Connected to another router, hooked up to a network to come up with 4 total networks. The other condition that they specified in that example was usable host addresses. They said you needed 45 addresses. You know what they did? They said 1, 2, 3, 4, 5, 6, 7, 8. They literally went out and counted all the end devices that are going to make up their network. And they came out with the number 47. Now, this classroom has 18 computers. The other classroom has 20 computers. If I am dividing the classrooms up equally, what number should I use? The classroom with the fewest number of devices or the classroom with the largest number of devices? If I'm dividing the rooms up equally. Well, let's think about it the other way around. Some days you drive to work and it's just you. Other days you take the family on vacation and there's 8 of you. Do you buy a sports car for the days that you drive just to work? And do you buy a minivan for the days that you go on family vacations, which is only once a year? Or do you buy a minivan and you drive that all year round? By the way, you can only afford 1 car. Sports car or the minivan. And occasionally got to haul the family around to, restaurants and everything else like that. Now Ian's up here, I'm going to go with the sports car, Nick. I got to protect my image. But eventually, you guys are going to become wiser and realize that having every kid sitting on each other's laps and a couple on the roof and a couple in the, trunk is going to eventually wear tiresome.
It's worth
It's worth it. Yeah. I remember you're married. You don't have to impress anybody anymore. So the minivan's all in style, correct? You build to the largest network. If I were to build my networks to only fit 18 hosts, and then all of a sudden I had this other classroom that has 20 in there, guess what? I got to re-demolish the whole thing and start over again. You always start with the widest network and let that set the tone. We good about that, folks? If I give you this number, you are to assume that that's the widest network. Okay? I have two conditions. One, I need to make sure that if I am to divide this network up, I need to be able to accommodate 3 networks, and each of those networks have to be able to handle 45 host addresses, usable host addresses. We're good about that. Folks, this is a teeter-totter. I can work from left to right, or I can work from right to left. Let's keep our units and let's keep our direction. If I'm working from left to right, what area am I working in first? So I'm right here, and I'm working my way in this direction. What area am I in right now? The network, because you see all ones right here, right? When I cross this line, because I can do that going from left to right, now what area am I in? Host. I could do the same thing by going the opposite direction, correct? If I start here, what area am I in? The host. And if I cross this line, what area am I in? The question becomes, and it always becomes this, how many bits can you steal from the host to be able to accommodate a network of this size? I'll say that again. In order to create subnets, you have to steal from the host. In other words, the line that I draw will no longer fall on an octet boundary. Does that make sense? Class A would have drawn the line right here. Class B would have drawn the line right there. Class C, I drew the line right here. I'm getting rid of classful addressing. I'm going to create a custom subnet mask that's going to tell me the width of my network and the number of subnets. So now I'm looking at this, and I ask myself, this is my host portion. According to Class C, the 4th octet represents the host. I can only borrow bits from the host. How many bits can I borrow to accommodate 3 subnets, which each network being able to have 45 hosts? Let's look at it from right to left. If I drew the line right here, oh, wait a minute. I got ahead of myself. Sorry, guys. I do this from time to time. I'm so excited to get this done. What if I drew the line here? Does it make sense to draw the line there? How many host bits did I leave behind? None. I made all 32 bits networks. Yeah, exactly right. What's the definition of a network?
2 or more end devices with,
2 or more devices connected together to share resources governed by the same set of rules. Through a common media, there you go. All right, there we go. Now, what if I draw the line leaving 1 host bit left over and borrowing all of these other host bits? In fact, at this point, I would be putting all ones here.
I don't think you wouldn't have any bits left over for hosts because you get the default, you get the broadcast in the network.
Thank you. You hit that right on. This is unacceptable because I only have 2 total addresses, but how many addresses do I really need? I need 1 for the network, 1 for each device, and 1 for the broadcast. This does not give me enough. Do you see this red number up here? If I leave 1 bit behind, I'm allowed with 2 hosts. That's 2 raised to 1 gives me 2 hosts. We're clear about that? This is never kosher. You won't be allowed to do that. At least not in this course. So if I draw the line here, notice I have all ones there and then 2 zeros afterwards, correct? That's as close as I can draw that line. So what would my network prefix be? /30, which we tend to use for point-to-point connections, correct? Because in point-to-point connections, we only have 2 hosts. So the key becomes, as Ian mentioned, you have to take your usable host address and add 2 to it, which is going to give me what? 47. And now I have to ask myself, how many bits must I leave behind? Listen to terminology. Not how many bits must I borrow, but how many bits must I leave behind to accommodate 47 hosts? So mathematically, this is the way we express that. 2 raised to what power will be able to accommodate 47 hosts? Make sense? 2 to the 5th would give me 32, right? 2 to the 6th? So 2 to the 6th gives me 64 host addresses. And remember my example, I said my largest network is going to be 60, correct? In this problem, it's 47. So that tells me 1, 2, 3, 4, 5, 6. Do you see we're going to count that way? 1, 2, 3, 4, 5, 6. I hit right on 64. And I'm going to draw my line to the left of that. And why am I drawing it to the left? Because I'm going from the right to the left. We're clear about that? That also means that I must put all zeros after the line, because this is the host part. And what goes before the line? So what becomes my new custom subnet mask? Because no longer can I use the default mask to represent this network. So what becomes the new CSM, custom subnet mask? Did these change? Did this one change? Did this one change? So from now on, the only octet that I'm really concerned about is the one where the changing is happening. So what is the new subnet mask for this one? This is in the what place? This one is in the, this one is in the, so why don't I take 128, add 64 to it, and I get 192. Good about that? So my custom subnet mask is going to be 255.255.255.192. I met one condition. What was that condition? I met condition number 2. Usable host. Right now, each of my subnets can handle 64 total host addresses. 62 usable, 64 total. How many subnets or how many networks can I now represent in this new system? Translation, how many bits did I borrow from the host for my subnet? You always borrow bits from the host to make subnets. It's no different than me coming in this classroom, destroying that desk, and putting up a partition wall. I had to take something out of this classroom to divide it. I have to steal from this host. I stole how many bits? 2. 2 raised to 2 gives me what? This 2 represents borrowed bits, or what we call subnet bits. Because remember, this line right here is my classful network, and the area in between it are the subnets. Live in an apartment building, and it's a multiplex building. We'll say it's building 1, like dorms on a college campus. Sometimes they give them names, sometimes just give them numbers. building 1, building 2, building 3. What if I write this notation down? 1.2.3. Let's say the first one's the building number. Let's say the second number is the floor number. What do you think the third number would be?
Room number.
Room number? And what if I put a /2 next to that?
A sub-room number.
Your
Or a
half of the
closet.
dorm room. Your half of the dorm room, right? Do you see the structure here? This is telling me the building. In the building, the rooms or the floors. This is telling me the size of the room. Is that clear? I borrowed 2 bits from my host, yielding 4 subnets. Good about that? Did I meet my first condition? Do I have enough subnet bits to be able to accommodate 3 subnets? In fact, do I have enough subnet bits to accommodate my network, my packet tracer activity? My packet tracer activity, or that logical topology that I drew over there, needed 4 networks. Do I have enough subnets to be able to handle those 4 networks? Do you notice as I steal more and more bits away from my host, what will happen to my host size? And what will happen to my subnet size? Hypothetically, let's say if I steal 1 more bit. Replace this with a 1. Now how many subnets can I handle? How many bits did I borrow? 3. 2 raised to 3 gives me 8, right? 8 subnets, but now how many bits am I left over with? 5. There you go. Evan has that one down packed, right? So that means I can handle 8 subnets, and each subnet can have a fixed width of 32. Do me a favor. What's 8 times 32? 256. Get rid of that calculator. Shame on you guys. Slap your right hand for even thinking about grabbing that mouse. Why should it be 256? What's 3 plus 5? 8 bits. What's 2 raised to 8? 256. If I say I need 4 subnets, and if I take 256 divided by 4, what would the size of each network be? Okay. I'll help you guys out using some monetary incentive. Keeping everything fair and equal, so I don't show any favoritism in this class. I got a $20 bill, and I want to make sure that everybody has their own equal fair share of this $20 bill. We're all in here for an hour and 25 minutes, so you guys should all get a slice of this $20 bill. Correct? How many people are here? 6?
6 of them.
Better spice it up a bit. Make the math a little bit easier for you guys, because I know it's hard. It's Monday. I got 4 additional 1s here. Plus a 20. How much money do I have in my hand right now? 24, and that's about all I have for this month. So I got $24 to get me through this month, but now I'm willing to share it with you guys. How much money do you guys walk away each? $4, right? Because you took the 6 of you and divided by the total, correct? According to a Class C address, what is the total host address I'm allowed? Class C. 256. The original problem said 3 networks. Unfortunately, what happens when you take 256 divided by 3? You're not going to get a whole number. You can't take a bit and cut it in half. You can't take that switch there and hold it halfway and get 50% light and 50% gray in this room, right? It's either going to be on or off. We good about that? I can't do that here. That's why I got to use my powers to come close to accommodating it without going under in this case. Does that make sense? The more bits I steal, the more subnets I get, but what happens to the size of the subnets? they become smaller and smaller. So what I like to do to illustrate this is using a number line. And you guys are going to love this number line because when it comes to the fourth octet, it's really easy to work with. However, when it comes to using the fourth, the third, and possibly part of the second, the number line gets massively long and it becomes overwhelming. So we will look at it from a decimal perspective because it's easier for us to first digest it that way. Then I'm going to come back to that board and we're going to go back to looking at it from binary. We clear about that? So let me take a number line. This number line is going to begin at what number, folks? Begins at 0. Let this number line only represent the fourth octet because I do not care about the first, second, and the third because that's what I bought. I bought a condo. I'm allowed to change the structure inside my apartment, but I'm not allowed to change the building. Does that make sense? So I only care about what I can change. If I can only change the fourth octet, tell me, when will this number line end? At what number will it end? How many bits make up the fourth octet? So where does the number line end? Because it's not going to be at 8, because those are 8 bits.
256.
Close. Because we go from 0. Notice these are solid dots. Does anybody remember this from math class? I had this like in 3rd or 4th grade, and it always like baffled me. What's the difference between an open circle and a filled-in circle? You know, a solid circle. You guys remember this from number lines? What did they say about open circles? Doesn't include it. I have what? Solid circles. Hence, it's inclusive. 0 to 255. Now, Michael's thinking that's a math class. Nick, this is a networking course. All computer stuff come from mathematicians. Now, here we go. I need 3 according to the problem, 3 subnets. But what am I given? I only have to borrow 2 bits, because if I borrow 1 bit, it's only going to give me 2 subnets, right? 2 raised to 1 is 2. So I have to borrow 2 bits, which will give me 4 subnets, correct? So is it all right if I divide this octet into 4 equal places? Just like you guys are dividing the money into 6 equal shares? So what's 256 divided by 4? Now I don't know if they're equal, but you guys are getting the idea. What would this number be? What would this number be? And what would this number be if I'm going to divide 256 by 4? Are you surprised to see 64? Look right up there, folks. 2 raised to 6 gives me 64. Wasn't that the width of our subnet? If I'm borrowing 2, I'm leaving 6 behind. So the width of each of my subnetworks, or my subnets, are 64. Do you see? I started with 0, added 64 to it, added another 64 to it, added another one. Do you guys see why we call it fixed width? The width of each of these areas are 64 wide. Let's call this one network 0. Let's call this one subnet what? What are we going to call this one? And the last one? No. 0 to 9, right, guys? 0 to 9. What's the network address for subnet 0? I'll start you off with the hard one. I'll do the hard part. 200.175.14. So what is the network address for this one? According to yesterday's class, I told you a network address has all what in the binary? Network address. And the host part has all what? All zeros. Okay, so we're going to revisit this up in the front with the binary. But the first number, right? All zeros is technically the first number. I didn't say the first usable, but the first number. What is the very first number on this number line?
0.
So why can't we make that the network address? You good about that? What's the network address for this subnet? .175.14.64. And what do you think the network address is going to be for this network? Notice the 200 is not changing. .75. .14. What? What about the last network? I'm doing the hard part for you guys. 192. Now that I got my network address for each of those subnets, what about my broadcast address? I'll do the hard part for you guys. Whoa! Did you get that? I wouldn't say highest usable, but it's the last address of that range. What is the last address for this range before you go on to the next network? 63. So what's the broadcast address for this network? I'll do the hard part. I can't believe you guys are letting me do this. 127? What about this range? 191. What about this last range? 255. Solid dot. And what about the numbers in between them? What do we call them? The assignable address block or the usable? So when I go to configure this, and what you guys are going to be doing in your packet tracer activity, my first usable address would be .1, correct? And my gateway address, or my last usable address, would be .62, the number right before the broadcast address. Make sense? What would I put in for my subnet mask for this network here? What's my new subnet mask? So .255.255.255. What? How do I teach my devices about these new boundaries that I'm putting in my block, in my house? Can I use 0? 0 is no longer applicable. What was the new one? I borrowed how many bits? I borrowed 2 bits to make 1, 2, 3, 4 networks, correct? I borrowed the 2 high order bits, so I borrowed 128 and 64 from the 4th octet. 128 plus 64 gives me. What about the subnet mask for this guy? Exactly. Why is it the same thing? Because they're still the same size. I haven't varied it. I'm not doing VLSM here. All I am doing is fixed with subnetting. So all these networks are going to have the same subnet mask, but they will not have the same network address. They will not have the same broadcast address, and they will not have the same usable host address. That's decimal. It's a nice little number line to divide it up. It's beautiful because 256 is really easy to digest. Could you guys imagine a number line that's 65,536 decimals long and try to divide that up to 1,000 subnets? No, I didn't think you would. So let's see what this looks like in binary. So I'm going to create a new table. I'm going to come over here on the right side of my binary work. And we're going to apply the principles. So I have subnets I'm going to call them numbers. Creating a table. Always a good idea to create tables, especially if you're new to this. Subnet 0, subnet 1, subnet 2, subnet 3. Eventually we'll move from this binary table to a decimal table so that when you guys start journalizing all your work, it'll make it easier for you to troubleshoot. But for now, we're going to do this in binary. I'm going to put the network address up top and the broadcast address underneath it. But it's in binary. I'm writing it in red. Whoops. That's because my blue marker just ran out, I guess. This is the 4th octet. I don't care about the others because they don't change. How many places are in the 4th octet? 1, 2, 3, 4, 5, 6, 7, 8. How many of those bits out of those 8 total host bits are being used to represent my subnets? Whoops. This is the old, I gotta fix this so it's the same thing now. How many bits did I borrow to make up for those subnets? Got the Christmas theme going on here. Do you see how I'm color coding this? The definition of a network address when it comes to binary terms is when you have all zeros in the host part. Do you see that I wrote all my zeros in black to represent the host part of my address? What does the red zeros represent? The subnets. Everybody's good about that? What am I going to write for my broadcast address? What is the definition of the broadcast address? The binary definition of a broadcast address. Remember, the network address is used to group devices logically, right? They're used by routers to forward packets on. If that's the case for the network address, when do we use the broadcast address? To everybody on the same network. Does that make sense? Now, sometimes I unicast by calling you guys out by your names. But I can send a broadcast message because remember, my packet header only has one destination IP address field, right? So I'll call you guys students. That would be your broadcast name. Hey, students, listen up. You have an exam next Friday. That's not the case, but I'm just telling you. That would be an example. I can see the people on YouTube. All right? We're good about that?
Should edit that part out.
Screw them. Definition of a broadcast address when it comes to binary is when you have what in the host? All ones. Let's go on to the next subnet. What would the next number be if this is my binary digits? What would the next binary number be if I have 0, 0, then all ones? 0, 1, interesting. And then what am I going to get after that? Zeros. Oh. And what happens when we have all zeros in the host part of an address? And isn't this the boundary to the next network? So what am I going to put for the broadcast address for this network in binary? 0, 1, right? Followed by all ones in the host. Fascinating. What's decimal zero in, what's binary zero in decimal? Do you see I have, ignoring the black for a second, just ignore these black numbers and just focus here. I have a 0, 0 in binary. What would that be in decimal? I have a 0, 1 in binary, ignoring all these others. What would that be in decimal? You got to ignore place. You're thinking that's 64 as in like the network address is 64. But I'm saying ignore the others and just assume this is the first couple, okay? So 0, 1 in decimal would be 1. What's 2 in binary? And isn't that the next number in line? What's 3 in binary? And you guys see how I exhausted all the unique combinations for my red bits? I can have 0, 0, 0, 1, 1, 0, or 1, 1. I cannot represent anything else without repeating myself. And you see how the black bits just reoccur? This is why I like memorizing things in binary, because I don't really have to memorize too much. Decimal, things look out of whack. Why did I go from 64 to 192? Where'd that come from? And binary, I got a repetitive pattern. Look at it. These zeros repeat. Each of these represent a new network address. But where do they change? Where the red bits are. If I had to convert this whole number back into decimal, I would get 0, which was the original network address of the first subnet, correct? If I were to convert this number back, Evan, you did this one, including the black numbers as well now, because I got to count the whole thing, because I want to convert the whole thing back into an IP address, I would get what? 64, which was subnet 1. What would this be? And what would this one be? This allows me now to handle across different octets, which we'll be doing tomorrow at the end of class. Okay? Now I told you the last 20 minutes we're going to be looking at the packet tracer, grabbing this theory and applying it. You guys should not feel comfortable with these numbers yet. That's why there are 4 pages of this just for doing tomorrow, and then over the weekend you guys will be doing another set of those problems. We'll be practicing those until you're sick of doing them. And we'll practice them more. Watch the video. Hopefully it's working. Over and over. What you should feel comfortable with is configuring those end devices on your packet tracer. Question now becomes is what numbers should we use? Not where to put them, but rather what to put in there. So Ryan, you're going to have to go to the public drive, so go to My Computer. Go to the P drive, open up the CSNT 1200 folder, and copy the subnet file, and then copy it to your documents, and then open it up. For the people that are watching at home, in Blackboard, you will have a link to the subnetting file. Just download it along with these examples. Folks, we did number 8 together. Let me just fill in the blanks in case you haven't filled them in yet. Class address was what?
C.
Default subnet mask was?
255 squared.
Yeah,
0.
cubed. So 255.255.255.0. Custom subnet mask was going to be?
255.255.255.192.
Yeah, so the same 255s, but then at the end, instead of a 0, it's going to be 192. What would the network prefix be? How many bits did we borrow to make up for more networks? 2. What was the original subnet mask? 24. So 24 plus 2 gives me 26 would be the network prefix. Total number of subnets? 4, because we borrowed 2 bits. Total number of hosts, that should read per subnet. 64. Number of usables per subnet? 62. Number of bits borrowed? 2. All right. You guys are the engineers. It's your network. You're administrating this. There are 4 networks here. Which one of these 4 do you want to make subnet 0?
Yeah.
The one with switch A in it? All right, so I'm going to come over here and click on my documentation tool. And then I'm going to click underneath switch A. And then I'm going to type in subnet 0. Then hit enter. And I'm going to type in network address of, what's it, 200.175.14.0. And what am I going to put in there for the subnet mask? .255.255.255. What? 192. No longer can I use the default. The reason why I can't use the default is because I have to teach my end devices that this address block is now divided. Here's one division, the second, the third, and the fourth. Notice I'm allowed to use first. That represents subnet 0. Don't get your zeros and ones mixed up. All right? Which one am I going to make for the next subnet? You want to make the one with the switch B? That LAN subnet 1? It's your call, guys. You tell me. So let me click on the documentation tool. I'm going to click underneath switch B. And I'm going to type in subnet 1. Then enter. Network address. What am I going to put in there for that? 200.175.14. What are you going to put in there, Ryan? For subnet 1. 64. By the way, folks, by now you realize by me doing this, I'm not actually doing any configuration. I'm just using it for documentation so I have a reference later. What am I going to put for the subnet mask? Bob. I'll start you out with the hard part. 255.255.255. 192, because remember, I'm making all my networks the same width. If I'm making them all the same width, guess what they get? The same subnet mask. So LAN 3 with the switch, I'll make subnet 2. Brian, what are you going to make this network? Subnet 2, what's the network address? And what are you going to make the subnet mask? Very good. Now, if you want to move it, you just after you because I'm typing, click on the white, then bring your cursor back over, click and hold, and you should be able to move the label. All right, what's the last network? Michael, I'll have you do this one. Where is that last network at? Between the routers? Yep. So I'll do the hard part for you. This is going to be subnet 3. And the network address is going to begin with 200.175.14. What? 192. And what are you going to do for subnet mask? I know it's ridiculous, folks, but I promise you somebody's going to screw this up on the next exam, and they're going to change it and make one have 192 and the other one having 224. Remember, I have not done any configuration yet. Here are the rules we're going to follow when we go to configure. Rule number 1, the lowest end device. In other words, the PC with the lowest number on your network is going to be assigned the first usable address. And then you will proceed sequentially from there on. So the next PC would be the next address. Your default gateway is going to be the last usable address. Going back to my binary table, what would the last usable address look like in binary? Last usable. Should it not be the number right before all ones? That means my last usable would have a 0 all the way down here in the very first bit, the last bit, if you will. Does that make sense? So this one would be what? What's the number right before 64? So this would be 63, but then the number right before 63 is 62. So this gateway for this network is going to be 62. What about this network over here? Look at the decimal number line over there. If the broadcast address for this network is 127, what would the gateway be? Because remember, the broadcast address is the last address, period. 126. What about this network? If the broadcast address for this network is 191, okay. So let's begin. I'm going to click on PC 0. Now, this is what I'm saying you guys should feel comfortable with. Going to the desktop tab, clicking on IP configuration, putting a dot next to static. Now, this is the part you should not feel comfortable with, because now you need to know what address to use. I'm going to type in 200.175.14. Ian, up to you. This is my first device on my first subnet.
Let's make it 10.
Oh, can we just make it 1?
Sure, we can do that.
First usable address. And then I'm going to click on the subnet mask, and lo and behold, I get hit with the default subnet mask. So I'm just going to replace the 0 with a what? Evan, 192? And what am I going to put in for the default gateway? 200.175.14. Brian? 62 on this network, correct, because I am on the first subnet. Let me close out of that. Go back to PC 1, desktop, IP config, click on IP address, type in 200.175.14. What? This is the next device on my network. Bob, if we used 1 before, which one are you going to use now? 2. What are you going to put in for your subnet mask, Bob?
Same thing, 192.
You got it. And what about your default gateway? 62, just like the other device, right? Because they're all part of the same logical network. That's what we're doing right now. We're assigning them the same logical network of 200.175.14.0. All right. Michael, let's go over to PC2. That's the other subnet. Tell me the information you're going to use to configure this device. So we have 200.175.14 for the IP address, followed by a what? .65. Very good, because the network address for this new subnet is .64. So the next device is going to be 65. Subnet mask number 255.255.255.192. Now, Michael, what are you going to use for your default gateway? So you're looking at the, what's that? 126, because you looked at the number line over there and you said 127 was the broadcast. So the address right before that's going to be my gateway. And the only reason why I'm making it that way is because that's me being anal following some kind of standard, right? Some people use the first address. To each is their own. But by being consistent, it makes troubleshooting so much easier. So I'm just going to copy that because I know I have to do the same damn thing to the next device. So for the next device, I'm just going to type in 200.175.14.66. Click on the subnet mask, replace the subnet mask with 192 at the end. And then I'm going to add my gateway by pasting that in there. All right, Brian, PC4, tell me your configuration method. What did you put in for PC4? It's on another subnet now. So 200.75.14. Hard part's over with. 65 was for the other network, right? We're down here now. Yell at me. We're down here. We're on 129 because we're on another network, so we have another network address of .128. So I type in 200.175.14.129. And Brian, what are you going to put in for your subnet? For your default gateway? So 200.175.14. What? 190, because you know the broadcast is 191. All right, so I click on PC5, click on desktop, click on IP configuration, type in 200.175.14. Oh, let's make this one 194. No, we can't do that. This one's going to be 120, 130, 130.
Yeah.
Yeah. Ian's shaking his head at me. Sorry for your. Sorry to disappoint you. Dot 190. Ooh. What are we going to do about the routers? Do you notice when I configured these, I did my local devices? And now I'm going to come back and do my routers. And that's just me trying to be a little bit more efficient with my time. I notice when I click on this router, I can actually configure two interfaces at the same time. So instead of clicking back and forth, I decided to save my routers at the end. But I need to pay attention. I need to focus on what interfaces represent what network. So if I hover over a red dot connected to the router, it should tell me what interface is plugged into that router that represents this network. I have FA0/0. That represents the LAN of router 0. Then if I come over and hover on the other red dot, which should be a serial connection, so that should read a little clock, because this is letting me know this is the DCEN, S0/0/0/0. So it's telling me it's the serial 0/0/0/0. Let's click on R0, so router 0. Let's click on the config tab. Over on the left, I'm going to click on the fast Ethernet 0/0. Before you can do anything with this interface, you must do this. And I always tell my students when you learn the iOS commands, it's really easy to remember this command. To turn on a port, you type in no shut. It's real simple to remember because if you don't have a port turned on, you can't use it, hence no shit. So you can remember that. It's not going to work for you if the port's turned off, hence apply the technique of remembering. Put a check mark next to the on box. You guys remember that when it comes to chapter 10 or chapter 11. Now that I turned on that port, and remember this interface represents the private LAN. What did we tell our end devices that this gateway was going to be for this network? 200.175.14. What? Remember, I'm on subnet 0. What was the last usable address? Should be 62, right? I told the other devices on this network that the way out of this network is going to device 200.175.14.62. I'm teaching this device that you are that man to go to leave this network. Let's click on the subnet mask. It adds a default for me, so I got to replace that last 0 with a 192. And at this time, I'm going to click on my serial 0/0. And what do you think I'm going to do to this interface before I configure it? Turn it on. Remember, this interface had the little clock next to it. Hence, I'm going to accept the clock rate of 2 million. And what am I going to put in for the IP address for this interface? Remember, this interface is on another network. So I have 200.175.14. What? It's on another subnet.
254?
You could do 254. You could also have done what? 193? It works for me. And what are we going to put in for the subnet mask? Notice this time when you click on it, it automatically put it in there. How did the router know to do that? Because you configured another interface on this router with the same 3 octets as this interface. So the router had to assume, since no two interfaces on the same router can represent the same network, had to say, oh, they must have subnetted this. So it calculated it out and said, oh, the next network address must be this, so hence 192. Make sense? Too bad it's not like that in the real world. Close out. Now you guys get to teach me. Brian, I'll start with you. We're going to go to router 1. Just to let you know, subnet 1 is going to be on fast Ethernet 0/0. Subnet 2 is going to be on fast Ethernet 0/1. And subnet 3 is on serial 0/0/0. Okay? So I want you to configure the gateway for subnet 1. So I click on config. I click on Fast Ethernet 0/0. What's the very first thing I do? Turn it on. What's the next thing I'm going to do? Which is what? 126. What are you going to put in for your subnet mask? So the IP address was 200.175.14.126. Subnet mask of 255.255.255.192. Looks good? I'm going to come over and click on Fast Ethernet 0/1. Evan, I haven't heard your voice in a while, and if your mom's watching these videos, she's going to be proud of you. What's the first step?
IP address.
Oh, first step.
Turn it on. Sorry.
There you go.
I did it here.
You didn't want me to say the magical key phrase of remembering this, did you? All right, now the next thing.
Where this is subnet 2.
Yep.
So the IP address would be 175.175.14. Do 129, or you could do the highest one.
Oh, you don't have much of a choice here because we already told the other devices what the default gateway is going to be. So when I'm in subnet 2, I said that my range went from 128 to 191. 191 being the broad. You got it. And if you click on the subnet mask, did it automatically fill out the right subnet mask for you because we already configured the first interface? All right, let's click on the serial. Ian, you've been sitting there laughing at Evan, so now I got to pick on you. What's the first step?
Turn it on.
All right. Now, here's a surprise. What's the next step?
IP address.
No, not in this case. Sorry. Loser. No, I'm kidding.
We gotta set the clock rate.
Yeah, we do, but
turn it
off. Yes, very good. So you redeemed yourself. Now I can make you a winner.
Sweet.
My last class, they were calling each other losers, so it just sort of trickled over. All right, now what are we going to do for the subnet mask?
Well, we gotta put the IP address in, right?
Yeah, sorry. Thank you. See, now I'm a loser. 200.175.14. Yeah, now remember, this is the WAN side of the router. Now, on the other router, you made .254, correct?
Yeah.
So you can't make this one .255 because that's the broadcast for that WAN. So what are you going to make it?
Well, you gave me the alternative of 193.
So you're going to go back to the beginning? We can do that. We can make it the whole spectrum. We could have also made it 253. To each is their own. It works for me. And the subnet mask should appear correctly. So I put 200.175.14.193. Let me close out of that. I have all green lights. Question. Can PC0 communicate with PC4? We have to teach the routers about the networks it doesn't know about. This might make a nice, interesting exam question. Can PC3 talk to PC4? I'll give somebody extra credit if you could tell me what command in the iOS to verify that this network is in the routing table as well as this network and that network. Remember, this router knows about the directly connected networks. From now on, I don't want to hear directly connected networks. I want to know the network addresses. So what should be in R1's routing table? 200.175.14.64, right? Because that's the network address for this one. What about this one? 200.175.14.128. What about this one? 200.175.14.192. Let's click on router 1. Let's click on the CLI command. It's our CLI tab. Hold the control key and hit the letter Z. Here's your extra credit opportunity. So hit enter. Tell me what would I type in here to display my IP routing table? Close. 5 more seconds. 4, 3, 2, show space IP space route. So Brian, you were really close. Just that IP. And lo and behold, you see our original network block, right? The Classful, but notice now it has a /26, and it says it's subnetted 3 times. Each of those network addresses that we talked about. So yes, PC3 can talk to PC4 because the router has an entry to get there. But PC0 cannot talk to PC4 because router 1 and router 0 do not know about the other's network. Okay? Save this. We're done. I'll see you guys tomorrow in class. Your homework assignment tonight is to do problem 9. Doesn't count against you. If you get it entirely right, I'll give you extra credit. Okay? So bring it. Do your work on the graph paper or whatever way you do it. Notice you're not going to be structured into a text file. You guys can write it the way you naturally would write it. Just bring it completed tomorrow. It's problem 9. It's on the next page, page 20.